Hello, this is the Promontory channel. Today we're going to take apart this engine. This is a D245, an inline 4-cylinder turbocharged diesel. Adding technical specifications as captions now. So, this particular engine was taken from a PAZ bus. The extended version, the one that has 2 passenger doors. So basically, this is an engine from Soviet times, from the middle of the last century, from the Soviet era. In the mid-80s, they added a turbocharger and changed the combustion chamber, making it the D245. And during Soviet times, it was the D214. So they're modernizing them. In the 80s, they added a turbocharger, and now some have a common rail system. There's Euro 2, Euro 3. Basically, it's still the same old D240. They're just trying to modernize it somehow, trying to do something with it. But in my opinion, it's not getting any better. I don't think it's any better than it was in the 240 version. It just causes more headaches, more problems. That's my personal opinion. Also, this engine, what's its problem? It's not very repairable. We have spare parts. Well, you can repair it, but what's the problem? The spare parts, the quality of the spare parts is really lacking. So I think that at the factory, whatever gets rejected, they send to the stores and sell as spare parts. I've personally encountered such a case. We bought a new engine block and immediately took it for inspection to check the bearing seats. The cover wasn't original, the diameter was wrong, plus there was no alignment. So we had to bore out the new block and restore the crankshaft seats. Only after that did we assemble it, and it seemed like everything worked more or less fine. But that's just an example of a big part, like the main engine block, you could say. And this applies to absolutely everything, whatever you touch. In other words, almost all the parts are of this kind of quality. That's why I think the engine's lifespan since leaving the factory is important. It's better not to waste your time or anyone else's. Just get a new engine right away, install it, and keep working with it for some more time. Rather than repairing your old engine every year or year and a half. That's just my personal opinion. So, what exactly happened to this engine? I mean, is it unclear what happened to it? Sometimes it makes strange noises, runs poorly, or shakes. Let's treat this as a scheduled repair, disassemble, inspect, find defects, and replace as needed. I'm going to take it apart now. Oh, I also want to mention that there should be a turbocharger here. The turbocharger is still on the bus, meaning they removed the manifold, but the turbocharger is still there. This is a turbocharged engine. We'll take it apart and check everything just like always. We disassemble, inspect for defects, clean, buy parts, and reassemble. They brought it to me with the frame, so the first thing I'm doing now is removing the frame, taking it off the mounts, disconnecting the frame, and then I'll start disassembling. So I'm taking off all these filters, hoses, the compressor here, basically everything on top. And then I start disassembling the engine itself. All right, let's go. So I removed the frame, disconnected the ground, put it on the table, made some supports, put the old sleeve and a piece of wood. Now the engine stands steadily. So now I'm removing the tubes, hoses, covers, basically all the attachments. Let's go. I'll remove the fuel pump right away. So I disconnected the oil supply to the pump, unscrewed one bolt. Now I need to unscrew the oil supply fitting, and there's another bolt behind it. Next, I unscrew these 2 bolts for the pump's extra mount. I remove the gear cover with 3 bolts, then unscrew the 3 studs holding the fuel pump drive and take out the high pressure fuel pump. That's it. I've removed the pump, and as you can see, I've taken it out, but the fuel pump drive gear is still under the cover. That means it will come off when we remove this front cover. Now I'm taking off the valve cover, the injectors and the cylinder head. that's how I removed the injectors. Well, here we can see that they were taken out recently, so something was already done with them, and that's why they came out so easily. Usually, if the injectors have been in place for a long time, you have to set up a puller here and remove them with the puller. Now we can see that the injectors came out easily. And I think these are actually brand new injectors. Next, I need to remove the heat exchanger, filter pump and water pump from this side as well. Then lay the engine on its side so I can loosen the cylinder head bolts. Basically, I've removed all the attachments. There's just this one left to take off. Now I'm laying the engine on its side because it's impossible to unscrew the cylinder head in this position. The force required is very high. I'm laying the engine on its side, unscrewing the bolts and removing the cylinder head. So I put it on its side and braced it so it doesn't move around. Now I'm unscrewing the head. So we can see that the fourth cylinder has some buildup. It's clear that it wasn't running in oil, it's wet, and you can see there's buildup here. Something hit the piston. We found the source of the knocking, but not the cause. What are these pieces and where did they come from? Maybe it's the valve seat that broke apart. We need to take out the valves now and check the valve seats. Well, maybe the piston got welded. Let's not guess. Let's find the cause now. So now, let's look at the piston. We can see some pieces on the piston as well. Here they are, shiny. And let's look at the cylinder liner itself. There are also scratches on the liner itself. That is, there are such grooves, longitudinal ones. You can feel them very well with your finger, meaning they are deep. From this side, we can see the liner is burned here with a real pit. I'll record it on my phone now. It'll be easier to focus and you'll see it better. Alright, so let's look at this fourth cylinder. We can see on the piston there are some marks, something is stuck there, and there are still some pieces left. We can see that on the liner there's a sort of pit like this, as if the liner itself was burning. It's strange, usually the piston burns. And on the opposite side there's a similar pit, but it's smaller. I could also assume the pin came out, but that's unlikely since it wouldn't cause this type of wear. Maybe it's somehow related to the injector. Or I also have a theory that the ring broke apart. If we look here, there's also a gap between the liner and the piston. That means the piston is burning in this spot. Honestly, I don't know. Most likely both the piston and the liner are burned through. Now we'll take out the piston and check. And maybe it's somehow related to the injector. We can see that we have new injectors installed. Maybe one of the injectors was supplying fuel incorrectly. And on the whole liner, right here on the walls, there are these longitudinal scratches. You can barely see them on camera, but you can feel them by touch. A cylinder that's in good condition looks like this, so everything is fine. And we can see that the condition of the block after this gasket is also perfect. We'll take it apart and see what's going on with the fourth cylinder. We'll take a look. The piston, the valves. We'll check the injector. Next, what am I doing? I'll turn the engine over, I'll set it on this surface, and I'll put some cardboard underneath so it doesn't get scratched. I have a guide here that will hold it, but I'll still put something underneath, and I'll be removing the housing. The clutch. Flywheel, taking off the oil pan, removing the pulleys, the cover in general. At the bottom of the oil pan, we can see fine metal shavings like these. So this is, I suppose, this is the partitions from the piston, where the piston rings are installed. These are the partitions that have crumbled. Next, I remove the oil pump, the pulley, the front cover, and the rear cover. The pump sucked in metal shavings, and as it spins, you can feel it jamming. I won't bother taking the pump apart, I'll just order a new one. So I remove the basket, took off the flywheel. Now I'm going to take off this cover where the oil seal is. Then I'll unscrew the housing itself and remove the housing. There's also this spacer in the back here which also holds the oil seal. So this system is actually from the 1950s. So I unscrew everything here by hand because all this clutch dust, when you work with air, the air lifts up all this dust. That's why I use a manual wrench. This way, the fuel pump drive gear is removed. So when installing it, you just need to align it with the mark and tighten it. By the way, its teeth are broken, so it needs to be replaced. If its teeth are broken, that means you need to look for more damage elsewhere. Oh yes, that's right. The intermediate gear also has a broken tooth, and the crankshaft teeth are broken too. So all the gears are damaged. We'll have to take a look now, maybe even replace everything, since one of them broke a tooth. It went further. Next are the intermediate gear, camshaft, crankshaft and fuel injection pump. This is installed in one spot. We can see that the shaft here got loose, the shaft was turning. So let's look at the cover again. We can see that right here has been rubbed, you can see the shine. That shouldn't be happening. And it got rubbed by this shaft here, which holds the intermediate gear. And if we look at it like this, we can see how much play it has. This shaft itself is removable. It gets inserted and pressed in there. And apparently it got worn out right in the block. So this can't be restored anymore. The block needs to be replaced. The shaft started to have play, the shaft started to move around. Accordingly, this gear here is wobbling and it's breaking the teeth on all three gears that it meshes with. I'll take it apart again and have a look, of course, but in my opinion the block can't be restored anymore. We'll have to install a new block. Alright, let's keep taking it apart. All right. So I still need to take out the piston sleeves and the crankshaft. Now I'm going to lay the block on its side again so I can unscrew the main rods and take out the pistons. So we can see that there were metal shavings in the oil system, apparently from the burnt piston. We can see our bearings were also scored. The crankshaft is likely damaged too. We'll check it. Now I'll remove the first cylinder to inspect it. Well, the first one should be fine, and then I'll take out the fourth cylinder and we'll see what happened there. So, you can see this spot here, it's like the ring is broken. This area looks like it was melted with a torch, which is very strange. So, it turns out that because of a faulty injector, the injector wasn't spraying properly. The spray pattern was too wide, possibly from a single hole. That's how the cylinder liner and piston ended up burned through. So I knocked out the pin and we can see that it's just broken in half. So right now it's really hard to tell what happened first. Either the pin broke because it was being crushed into pieces here, and because of that it broke the ring. Then the ring with those pieces started scoring the cylinder liner and piston. Or maybe that's already a consequence. I don't know. I need to think about it now. At the moment I can't think of any options offhand. So either this is the cause and that's the effect, E, or vice versa, this is the cause and that's the effect. E, yeah, that's an interesting point. I'll wipe it a bit now and film it in more detail. The piston pin split in half, not across but lengthwise, exactly lengthwise. So, the pin split in half. What do I think? I still believe this indentation on the piston and cylinder sleeve was the cause. At first, I thought it was burned through since it looks almost the same. A piston burns through similarly. Anyone who's seen it knows. At first, I thought it was burned through, but of course I'll check the injector on the test bench to be 100% sure that it's not leaking and that it's working properly. But still, after looking at the piston and the piston pin, I came to the conclusion that this is our reason. The broken piston pin is the cause. That is, it started to get hammered there, shaving off metal. Metal shavings from the bushing, shavings from the piston itself. And here, for example, these little pieces, look how it was polished. This could be a piece of the pin itself. It ended up right here. It moved back and forth. The piston worked, so these small parts wore out both the piston and cylinder sleeve. For example, this wasn't the only one. So you can see how it was worn down. It became like a sea pebble. It was rolled and polished in these spots. The second point is that we don't have a through hole from the combustion chamber. If this was a burnt piston, then this groove would go into the combustion chamber so that the gases could get in and keep making their way through. But here we see that on the contrary, there's a thickening in this spot. In other words, it packed in this metal shaving. That was our reason. I assembled the engine, I think in 2018, so 2 years ago. I don't know how many miles it's run, it's hard to say. We installed a new piston assembly. I'll check which one it is and who made it. And most likely, the piston pin was defective. That is, it broke under the load. So, what did I say? The problem with these engines is the spare parts. The quality of the parts you can buy in the store. So the piston pin had some defects and it broke under load. Well, we can see what happened. We have a situation with this engine, and it's actually quite interesting. The piston group must be replaced, including pistons, sleeves, one connecting rod, and the cylinder block, because the axle got damaged in the spot. Maybe it's somehow related, I don't know how yet, but maybe it's connected somehow. If we see that our bearings already have these kinds of scuffs, and on this bearing you can see that it's packed with metal shavings, but it hasn't started to score yet, although there are a lot of shavings. Maybe metal shavings started sticking to the thrust washer here as well, and the gear got stuck. Here we have the oil channel right in this spot. There's also a drilling on this shaft itself. Here they are. The oil gets in here and it comes out here. And this gear rests against this washer. So this washer here is a thrust washer. So because of the slanted tooth, it pushes it this way against this washer. So maybe this is why the metal shaving started to go here. And this washer began to seize up, it started to weld itself, and maybe the gear also started to seize onto the shaft. So I think all of this happened exactly because of the metal shavings. That's what caused this situation. So now this mounting spot for the pin for this axle is worn out. I have no idea how to restore it. I honestly don't even know. And I don't even want to know. That's why we're throwing out the block as well. The crankshaft is questionable because there's wear on it. We need to take it out and check it now. Ground crankshafts on this engine supposedly don't last. So if we have to grind this crankshaft, it means it won't work for us either. In the end, all we have left from the engine is the cylinder head, although we still don't know what condition it's in. We'll take it apart and check it too. Maybe we need to fix these two valves. As for the rest, I think there shouldn't be any issues. Plus, all these covers, oil pans, and gears need replacing since the gears are broken. So we only have the cylinder head, the covers, the camshaft, and 3 connecting rods left. Everything else is for disposal. Let's see what decision is made. Too bad I'm not deciding I'd scoop it all up with a shovel right now. I would throw all this scrap metal out the window. I can't stand these engines. Unfortunately or fortunately, no, I'm the one making the decision. So we'll wait. First we need to take it apart, then explain the whole situation, his thoughts about it, and then we'll see what decision will be made. Alright? For now, let's take out 2 more pistons and remove the crankshaft. I removed the crankshaft, it's dirty and not yet wiped, but we'll take a look at it later. For now I wiped the bearings and we can see that every bearing has scoring on it. Metal shavings from this pin entered the oil system, causing scoring on every bearing, some very deep, so maybe this is what caused it. The failure of the intermediate gear. That is, this viscous aluminum shavings also got packed under it. It got jammed and pressed in there, and it started turning the shaft in the block. Started jamming and started turning the shaft in the block. I'm almost sure 90%, maybe even more. This is what our connecting rod bearings look like. This is what the main bearings look like in the engine block. So our work day is almost over now. Tomorrow I'll take out the sleeves and I'll also take out the lifters. Basically I'll finish up with the block here tomorrow. I'm curious who made these pistons and the piston assembly. It was a complete set, sleeve, piston, rings and pin. I want to find out now who this manufacturer is, so it will be good advertising. Here's the piston after cleaning, so we can see that some inscriptions have appeared here. We see the Rostendat inscription, some other symbol, and we can see the manufacturing date, September 18 above. So I'm saying I did it exactly 2 years ago. We see the inscription made in Russia. We see a QR code, but I tried to scan it. Curves, and the camera doesn't pick up this QR code. It seems it's slightly damaged. There are no markings or signs showing which company made this piston assembly. I found nothing else. You could have found out using this QR code, but the camera can't read it anymore. we look and see that we even have a crack on the sleeve here, right in this spot where you can see the groove. And on the opposite side, we see a crack. Alright, I noticed something on the sleeve. There's also a mark. Here it is. I'll take a picture with my phone now and insert the photo. Doesn't tell me anything. What manufacturer is it? But maybe someone knows. If you do, write it in the comments. Fully disassembled, just the bare block remains. I haven't removed the camshaft bushings yet, but that's not necessary for us. So what do I want to say? As I said, many parts need replacement, including the block, piston group, and possibly the crankshaft. By the way, I haven't checked it yet, but that's not so important anymore. Right now all the gears need to be replaced. All of them are broken, so this axle needs to be changed too. Well, basically we just have the head left, covers and camshaft. So my opinion, what would be the best thing to do with this engine? It would be to scrap it for metal and keep the good parts for the future, just in case. Buy a new engine for this bus. That's my personal opinion. That's what I would do if it were my vehicle, and so on. But I don't know yet what decision will be made. Maybe there will be a repair or a new block, piston assembly, etc. I don't know what will be decided yet. I don't think it's worth buying new parts and assembling this engine, since, as I said, the parts quality is lacking. After assembly, there's no guarantee that in 6 months or a year this won't happen again, which is actually common with these engines. So basically I don't like these engines at all, and this might even be one of my least favorite engines, if not my absolute least favorite. I tried to recall if I'd ever seen a pin split lengthwise like this before. In 23 years of working with all kinds of engines, I've never seen a pin crack lengthwise like that. I'll keep this pin in the archive. By the way, I've seen a lot of things happen to engines. A brotherly hand helped out. I've seen crankshafts break and rods twisted. I took out a small piece like this from my archive. I've kept it for about 15 years. Of course, I could have held a contest and asked where this is from, what it is, and so on. But I'll tell you what it is right now. This is part of a Mercedes crankshaft, so you can imagine what happened to the engine. Pieces like this were flying around like shrapnel, as if a grenade exploded inside. So this here is the main journal, and if you can see here, the shaft was ground in this spot. The shaft was ground incorrectly. There was a sharp 90-degree step here. It happened about 15 years ago and left a piece like this. This pin will also go into my archive now. I'll clean it up as well as an archive of interesting cases, so to speak. This finger will join the same collection. Well, I'll also say that I'm 100% sure that the reason for the engine failure was this pin, specifically this defective pin. In other words, it's a factory defect. I'm 100% sure. It worked for a while, handled some loads for a while, and then at one point it just simply broke. And actually it's probably going to be hard to hear that kind of sound, because this engine is very noisy by itself. It runs loudly. Those who have dealt with them know. So if this pin hadn't broken, this engine would still be running. Well, I don't know for how long it would have kept running, but judging by everything else, basically everything was more or less fine. The only reason it failed is exactly this defective piston pin. quickly explain the situation, the decisions made, and more. So, this is an absolutely new block. I'll be assembling it. It's a new block. We'll return to it soon, and I'll share more. This is our block. It's broken. This is the place where the shaft for the intermediate gear is located. This block is going to scrap metal. Next, we got another PAZ bus with the same engine, recently rebuilt and with only about 20,000 kilometers on it. The mileage is low. I'm not sure about the time, but it may have been rebuilt 6 months ago. What's wrong with it? The engine was rebuilt with all new parts, pistons, bearings, etc. So what's the issue? When the first frost came, as we can see, it froze and cracked. So right here, a crack appeared like this. They tried to weld it right there. As we can see, they welded it, smeared something on it and patched it up. But as we can see, the coolant is still leaking here, so it didn't give any result. Here we can see the crack from the inside. It goes like this. There's a big crack here. So it turns out it didn't give any results. So we had an engine with good internals, but with a bad block. It turns out that block is for scrap, and this block is for scrap too. We removed and disassembled the engine, and now my task is to transfer everything from this block, absolutely everything, onto this new block. That's what the repair will consist of. We won't be using any new parts here. Everything will come from that block, the one that was stored. The only thing is a set of gaskets and a set of main bearings were purchased, since the crankshaft was also new. And I think right here on this journal, on the shaft itself, there seems to be a small scratch in the area where the oil channel runs. The chamfer wasn't done well, but we'll check and fix everything. So this block is new. It was brought in and it was all covered in grease. I put in the washer, cleaned it, blew it out, so the block is already prepared. So I've also already partially cleaned some parts from that disassembled engine. I filmed a bit of this process. I'll insert the footage now. I've already cleaned some parts, some remain, and now we'll clean and assemble as we go. So what's our task right now? We take the parts from the defrosted engine, clean them, wash them, and install them on this block. We're not putting anything new in, just swapping them over, that's all. So this block was purchased for around, I don't know, 40 to 50,000 rubles, I'm not sure exact. I suggested buying a new engine, which I think would have been more reasonable and better. That's just my opinion. The engine is very expensive, so that's how things are. I'll assemble this engine. I don't even know which bus it will be installed on, either on a bus from the Privet series by a domestic manufacturer or on a bus with a towed engine. But basically, it doesn't really matter for our video. So, now we're starting the assembly. First of all, here we have a box with main bearings, and we also have this magic little bag with spare parts. Since this engine is a domestic Автопром engine, a new block, we still need to finish some things ourselves and add some parts ourselves. So in this little bag we have guides. We see 4 guides, which means 2 for the rear cover and 2 for the front cover, for the front lid. And there are also these plugs. Here's one plug and here's the second one. We install them into this channel where we have the drilling of the oil channel. So we need to put a plug on this side and we need to put a plug on this side as well. Also, before we had to install these nozzles ourselves. So here we have oil nozzles, if you can call them that. So from this channel we see one tube and another tube, and it's directed somewhere towards the cylinder liner. Where exactly it sprays is hard to say. Well, basically somewhere over there. We have one nozzle here and another here. On this crank pin there's also one here and another here. So before, you also have to hammer in these little tubes yourself. Now we see they're already installed in the block, so we can clearly see the progress of our domestic auto industry. But by the way, I forgot to mention that this engine was taken straight from the store to the machine shop, right? So, they put it on the machine, checked the diameter of the machining for the main bearings, and also checked the alignment. They said everything seems fine. But I'm almost sure this engine won't work. Something will definitely happen to it, because this is a D245 assembled from spare parts. That's why I'm just sure. No matter what you do with it, I try to consider everything, did everything possible, but it never lasts 100,000 and something always goes wrong. It could break the shaft or cylinder sleeve, damage bearings, weld itself, burn the piston, crack the head. Anything can happen. That's why I have this attitude toward this engine. In general, we try to anticipate everything as much as we could, did everything, checked everything possible, basically. Only in rare cases does this engine run well and work after repairs. In all other cases, something is bound to happen to it, and it does. In a word, my least favorite engine. I just don't like working on them. In general, the engine itself, the design, I don't like anything about it. Before I start assembling, I need to install this shaft, which fell out of that engine. I need to install this shaft and put in the guides at the front and back. So, I'll take this shaft from the old engine, the one that got frozen. So, I made this kind of puller, put on the flange, a washer from the same flange, screwed in 2 studs, and used nuts to pull the shaft out towards myself. So I hammered the shaft a bit, but not all the way. It should be nearly flush here, but I left it sticking out slightly just in case. When I install the gear, I'll need to adjust the installation depth to control the axial movement of this intermediate gear. Next, I glued the plugs in place and also hammered in the guides, but not all the way, not until they stopped. Later, if needed, the cover will press them in deeper. And on this side as well, I glued the plug in place, but not all the way. Now I'll remove the main caps and also try to set these little tubes in a bit deeper. I mean, I see this here and it feels like it could go a little deeper. Then I'll install the sleeves, put in the camshaft, the front, this intermediate plate, and so on. So let's start the assembly. Alright, I'm starting the assembly. First, I install this intermediate cover. Then I'll put in the pushrod and the camshaft. Next, I'll install this gear. Flip the block over and install the sleeves. That's the scope of work for now. Let's go. Alright, I've installed the camshaft. Here, as you can see, we have this screw for a screwdriver. I'm tightening it with a valve screwdriver and a wrench. This one's a simple 14. The camshaft is fully installed. We're setting the timing marks. Here are the timing marks. And now I'm going to install this intermediate gear. So it also has marks on it. This one is for the crankshaft, marked with a K. The camshaft is marked with an R, and T stands for the fuel pump. So right now I'm aligning it with the camshaft, and the rest will fall into place later. If I align it and start turning, the marks I'll explain and show how they move later. Alright, first I install the washer, then secure the gear with 2 bolts. That's it. The gear is in place. You can see there should be little place so it can move back and forth. So about the marks, I want to say this. If, for example, I turn this gear 1 full rotation, these marks here will no longer line up. As you can see, after 1 rotation and bringing the camshaft back, the marks are now off, and so on. You can do a lot of rotations. Here's another one, and the marks still don't line up. A 3rd rotation, the marks still don't match. A 4th rotation, and so on. You can keep turning it endlessly and the marks never line up. I haven't counted the rotations. That's why it makes sense to install it after the crankshaft. That is, since later you set the mark here, and then put it on. But I'll check later, and if something goes off, I'll take it off and reinstall it. So now I need 4 turns in the opposite direction. We can see that now my marks are aligned. Since it's intermediate, it shouldn't really matter. Suppose after setup, I turn it twice and the marks still don't align. That doesn't matter anymore. The main thing is that initially all these timing phases were aligned. That's it. Now these gears are installed. Now I turn the block over and install the sleeves. The sleeves are also old. Clean them, especially the spots where the rubber seals go, and now I'll install them. And the first thing is how much the sleeve protrudes, the block, the cylinder block, and the limb. So what I did was install the sleeves in their places. That is, I have them placed 4th, 3rd, 2nd, 1st. I installed and pressed in the sleeves without rubber seal. Regular sockets work well. You don't need special tools since large sockets fit perfectly. Now I'm measuring the sleeves protrusion above the cylinder block. It should be 0.05 to 0.11. I'm taking this homemade tool of mine and setting it up on the block. We see that the block is at 0. Moving to the sleeve, we see 0.08. We see the block is at 0. The sleeve is 0.07. The block is at 0. The sleeve is 7. And we check the other side as well. 0.7, 0.8, 0.7, 0.7. we see that all the sleeves have a protrusion of 7 to 8 hundredths even when clamped. This edge here sticks out above the cylinder block by 7 to 8 hundredths, which is basically normal. That's all. Now I remove these clamps, take out the sleeves, and then install the sleeves with the rubber seals. So I'll be installing the sleeves onto these rubber seals. They're silicone, basically fine. The main thing is they shouldn't be like these black ones, the ones that are black. They usually come in gasket sets. Those are really bad. These are a bit better. So 2 seals are installed in the block. Each cylinder gets 2 seals. The sleeve itself is empty without seals. My pistons are ready. I won't remove the rings or measure anything. Everything is fine. What should I do next? Next, I'll install the crankshaft in the block. So I won't be washing it so that these journals don't get rusty and I don't have to deal with that later. I wiped it with a rag and used compressed air. And now, as I said, I need to take a diamond stone, this kind of diamond stone, and use it to go over these, basically the chamfers of these oil channels. One of these channels has a small burr somewhere, so to speak, and it's scratching the bearing, not badly, but the bearing was scratched. I laid the shaft, installed the bearing shell, applied assembly paste, and set the timing mark. As you can see, my camshaft is aligned and the crankshaft is visible. The fuel pump, marked with a T, will also be here. Next, I install the main bearing caps and piston band. Install bearing and main. Install. Crankshaft installed and tight, now installing pistons. We're keeping the old piston rings, the old bearings, and I checked the piston pins, they seem to be intact. So I've prepared the nuts and the drift. Now I'll take out the bearings, wipe the bearing itself and the area under it. I also want to mention that my pistons are marked first, second, third and fourth. So the pistons are, everything is in the crankshaft, is the main bearings up and the connecting rod bearings are tight. Next, I will be installing the covers, the front one and the rear casing. I've washed, cleaned and prepared them. First I installed this gear, which is for the oil pump drive. Then I installed this dust cover. Well, not a dust cover, but an oil deflector. It goes on like this and protects the oil seal from oil. So, before putting on this gear and the oil deflector, I check the timing marks. Both the camshaft and crankshaft line up EU. Here I have the mark for the fuel pump. So I take the gear for the fuel pump drive and install it. So I need to somehow secure it here now. I arranged the rubber bands to stretch, and as you can see, my marks are aligned. Then we add another gear to the process. The power steering is also driven by a gear. And then we add another gear here. We can see these teeth here. The compressor is also installed here, so the compressor drive also comes from here. So there are 1, 2, 3, 4, 5, 6, 7, 8 gears involved in this mechanism. So after we've installed the cover, I remove this rubber piece. Now this gear won't go anywhere and its tooth won't slip. So through this cover, the power steering pump and the fuel pump are immediately attached. That's why I installed them right away, so that everything is tightened with these bolts. I installed the high pressure fuel pump. Like these 2 mounting bolts and 2 long ones go through the entire cover. So I also connected the oil supply to the pump here, meaning there's a channel here, and this is the oil supply for lubricating the pump. Setting timing marks isn't required when installing the high pressure fuel pump. Well, provided that the gear is installed correctly, as I showed. Here we have 3 studs and you can't install it any other way. They're offset. Adjusting the ignition takes about 5 minutes, plus or minus. Now, I'm putting the cover here with the bolt inside, and then I'll install the rear casing. So, I've prepared the cover, the gasket and the bolts. Also, we can see that the designers of this engine took care of the mechanics who will be assembling it and made this special shelf so it's convenient to place the bolts. Next, we'll install the flywheel housing. But first, we need to install this additional bracket for the housing. Bolts are screwed in here to hold the oil seal cover. I've installed the housing. Next, I'll install the oil pump before the flywheel and clutch. Next I'll be installing the oil pan. I've cleaned and prepped the oil pan, and we have end gaskets. They look like two rubber seals like these. The side ones look like these two pieces, my gaskets. Let's double check to be sure. All is in order, oil pump installed, main and connecting rod bearings tightened. Everything's ready, we can install the oil pan. No. That'll be almost no. I installed the YB. Installed and tightened the oil pan. Tightened up well. And on the wall. Because the gasket is made of pyronite, so there's really good tension on the bolts. Unlike using a rubber or rubber core gasket, which has no tension and just flattens and squeezes out, pyronite gasket should hold fairly well. So next I installed this bracket. Here we have the front mount, meaning the engine rests on these two supports. I installed the pulley and tightened it. I also installed the oil filter, not the filter itself, but the place where it mounts securely. That's it. Everything is assembled here. So what will I do next? Now I need to lay the engine on its side. So I'm going to tilt it like this. And then I'll install the cylinder head. So I've laid the engine on its side, propped it up like this so it stands steadily, and now I can install the head. But before I install it, I want to release the valves and take a look. Basically, I'll explain why I want to release the valves. So there's information that when these intake manifolds were disassembled, either bolts, washers, or something else might have fallen in. I did take a look and blew it out, and it seems like there's nothing there, but it's still better to release everything and check to make sure the manifolds are empty. Nothing got stuck anywhere, because the consequences could be pretty bad later on. So now, picture ne pučtele. Bez potom so now I'm disconnecting the valves. Checking everything, and it's all good. I'll wipe it down. Put everything back together. And install the head. I've disconnected the valves, so let's check. Everything looks fine. I didn't find any bolts or nuts. I'm not sure if there were any here. Well, alright, that's not really important. The main thing is we took it apart and checked this carbon buildup. Clean it. Now, wipe it down. Blow it out. And I'll start back together. And then I'll stop. Pull it out. No. Up. I've checked the head. Hey, Separaplastu. The head is ready to be installed. I'm installing it. Separaplastu. I'm installing it using the chain. Putting the chain on and tightening the nuts. Tightening the nuts. I've prepared the bolts for installing the head. Now we take the gasket and we take these fluoroplastic rings. and throw them in the trash. We're going to install it with this kind of gasket, metal gasket. Basically, only these seem to last at least a little bit. The metal asbestos one that I threw away doesn't hold at all. Not at all, you can't get anything out of it. So, there's an instruction here. I'll take a photo now and add the photo. It's described in great detail how to install it, how to put the bolts in, the tightening torques, and so on. So I installed all sorts of covers, plugs, and so on. Basically, I put in all the small stuff, and I want to say the following. Basically, everything I can assemble on the table, everything I can put together here in the workshop, I've already assembled, I've already done. After installation, the engine is assembled on site. Push rods, rocker arms, valve cover, and air manifold are all installed there. valve adjustments, and everything else are done on the bus, which is a unique aspect of our domestic automotive industry. The assembled engine won't fit in the bus. Here we also installed the compressor. As for the compressor, that's still up in the air. Maybe there will be a new compressor, maybe just a different one, but for now it's not here. I'll put a plug here for now, since there's no compressor yet. I installed the starter. Basically everything I could, everything I took off, I've put back on. So shall we go? As you can see, that's how it works. Honestly, it's pretty good for this engine. Let's see how long it lasts and how far it goes. I'll keep you updated on this engine's future. If anything happens, I'll post a video on the channel. I expect it to last at least 100,000 to 200,000 kilometers. God willing, that'll be in 2 years or even 5. Alright, that's the video. Thanks everyone for watching. Good luck to everyone. Goodbye.